C. Selection of locomotives. Analysis for question. The selection of locomotives is based on the average space and the daily switching requirements of the installation during the both base times and mobilization. Majority of the DoD rail operations, utility railroad, and the intraplant in nature characterization relatively short distances, switch movements, usually consisting of less than 10 railway cars per move. The distance interchanging with the commercial railway car is to the installation classification. Receiving yards rarely exceed 5 miles, Therefore, this criteria, commercial railway cars to assign the promotive power are not generally applicable to the operation of the DoD installation. Daily average gross of the trailing load, the GTL, gross trailing load switching requirements of the installation should be used in computing drawbar pulley needed for the assigned locomotive during the peak of the and periods of an extra switch move required of the handling it above the average volume of the car's situation. Preferable acquisition assignment of the maintenance of the locomotive larger than in a requirement for the installation management. The objective is to assign the locomotive minimum size horsepower available for the effectively performing switching requirements in the installation. Section 6.2 and 6.3 contain the formulas factors to be used in the selection of locomotive as well as the characteristics of the locomotives owned and operated for the DoD components. C2 Chapter 6, Part 2, the formula factors of the locomotive section. The locomotives will be selected based on the consideration of the following factors. Weight on the drivers. The weight on the drivers expressed by the short tons is the weight supported by the driving wheels of the locomotive. It does not include any of the remaining portion of the locomotive's weight. The weight of the drivers on some locomotive Department of Defense and is shown in the tables of Chapter 6, Table 1 of those not listed in the table specification issued to the purchaser for the using of the railroad manufacturer must be consulted. Traction effort, the force developed by the locomotive driving wheels parallel to the rail to move locomotive cars. The force expressed in pounds directly proportional with the locomotive horsepower, inversely proportional to the locomotive speed. The tractor effort of some locomotives used by Department of Defense is contained in Chapter 6, Table 1, and it shall be data if not where such data are not available. Traction effort may be determined included in Chapter 6, Part 2, Section 2.1, 2, and 1, 2, Part 2, Section 2, Part 2 below. Starting traction effort. The TE, starting traction effort, the powers of the locomotive can be exerted for the move itself and loading the hauling of the deck from a dead stop. Is corrected closely to the adhesion of the driver's wheel maintaining the rails. The tractor effort exceeds the adhesion of the factor the driving wheels will supply. Normally, adhesion with the rail are dry at 30% of the weight of the drivers. When the rail are wet, the factors are reduced to 20%. The planning of the purpose of the 25% is used. For a diesel locomotive weighing 80 short tons and 73 metric tons or 1,600 pounds, 80 tons, or 72,574 kilograms. The driving wheel for the starting tractive effort is computed as follows. The weight of the driver is 1 pound per kilogram over the 25% of the adhesion factor. The locomotive weighing, the diesel locomotive weighing short tons, 160,000 pounds divided by 4, which is and 40,000 equals the 40,000 pounds. Continuous tractive effort. Continuous tractor effort is effort required for the locomotive to keep the train rolling as in started. As momentum training increases, the factor effort is necessary to keep the train from moving, diminishing rapidly. As hence, the diesel electric locomotive cannot continue to exert the same force pulling and they intended for starting the load. Continuous traction effort of the diesel electric locomotives is rated approximately 50% of the starting traction. Approximately 50% of the starting traction effort of the diesel electric locomotive weighing 80 short tons to 73 metric tons, 1,600,000 pounds are on the driving wheels. The continuous traction effort is computed as follows. The traction effort over the traction effort C is equal to traction effort times 2, which is 50%, and the traction effort the pounds. Traction effort pounds divided by 2. The draw pulley bar draw pulley is a force available for the pull of the train, deducting the track effort of the engineering required to move the locomotive itself. Planning 20 pounds per total locomotive weight is in the traction effort as follows. Total locomotive weight is 100 tons divided by 22,000 pounds. The traction effort minus 2,000 pounds of the DB draw bar pulley. Traction effort of the traction effort over the 2,000 draw ball pulley pans and draw the draw ball pulley traction effort over the 2,000 of the draw ball pulley equal to over the 4/4 of the traction effort equal to 50,000. The traction effort of the 50,000 by the 50,000, the half of the get it started is 25. The draw ball bully 25,000 minus 2,000 pounds is 2,300,000. Maximum draw ball bully can exert the lowest speed up to 10 miles per hour and an hour. Limited length of time higher than speed does use electric locomotive. Draw ball diminishes. Draw bar pull diminishes rapidly because of the electric generator. Traction motor cannot be holded on the heavy starting voltage. Amperage would burn out the load and continued long time after the locomotive reached a speed of 10 miles per hour. However, the steam locomotive retained the initial draw bar pull at all speeds. The same manner is retained the tractor effort as at all speeds. Rolling resistance, the RR, the force of the components acting on the train in the direct parallel while with the track, which tends to hold and retard the train's movement. The rolling resistance components of the rolling resistance are frictions between the railheads and the treads of the flanges on the wheels. Resistance during the undulation of the track is under the moving of the train. Internal traction of the rolling stock resistance is still higher than absolute figure is used by the rolling resistance, but experience indication of the safer average of the values. Rolling resistance are in table C, chapter 6, table 2. Chapter 625, Grade Resistance. The grade resistance is the resistance offered by the grade of the progress of the train caused by the action of the gravity which tends to pull on train downhill. In the military railway planning uses the factor of 20 pounds multiplied by the percentage grade resistance in the pounds per ton of the trailing load of the train. The curve resistance. Curve resistance or resistance offered by the curve of the progress of the train. Entirely satisfactory theoretically discussion of the curve resistance had been published. However, the engineering in the United States usually allows only 0 to 8 to 1 pound per ton of the train per degree of the curve. The military railway planning factor the 0.8 pound multiplied by the degree of curvature. The weather factor W. The weather factor reflects on the percentage adverse effect of the cold, wet weather and on the hauling power of the locomotive. Experience tests and have proved whether the outside temperature drops below 32 degrees Fahrenheit, the hauling power of the locomotive decreases. The table of Chapter 6, Table 3 indicates the weather factor, the percentage verifying the degrees of the temperature. Chapter 2, 6.272, ordinary wet weather regularly local temporary considered observed average figures. However, countries have extended the wet session of monsoons and fogs. The loss of traction effort and the slippery rails may prove serious in sanding facilities and lacking or inadequate the applicable reduction made or the judgment of the general traction effort will be not reduced in less than 20% of the weight of the drivers. The gross train loading, whether the diesel electric locomotives are operated in the multi-unit gross training load is equal to the sum of the gross training load for all locomotives used. So whenever the locomotive is not electrically connected, multiple unit train operation. When the steam locomotives are used in tandem, double-headed, and then push services 10% of the total gross training load of the deductible because of the human element involved. The gross training load of the maximum tons of locomotive can move under the conditions, for example, curvature, grade, weather, and is determined from the combining factors discussed in Chapter 623 through 627 above. The formula for gross trailing loads as follows. The gross trailing load. The gross trailing load is the draw bar pull times the weight. Across the resistance, across the rolling resistance over the graded resistance, rolling resistance plus the graded resistance plus the curvature resistance. Divide the great gross training load and the draw pulley bar and the weather resistance. the draw pulley bar times the weather resistance divided by the rolling resistance plus the grading resistance plus the curve resistance. When multiple unit diesel locomotives, the pushers are used by the gross trailing load of the equal to the sum of the gross trailing load of all locomotives. The characteristics and planning factors some of the DoD locomotives. This is a characteristic planning factors of the locomotives, the type of locomotives, the gauge of the inches, the weight pounds, the length of the over the couplers, the extreme width, the extreme height, the starting of the 30% adhesion of the continuous, not no the horsepower is the curvature, the minimum radius, and the fuel capacity. All over these 120 tons diesel locomotives, these are charts. They are the planning factors of the sum of the DoD from the DoD locomotives. Average value of the rolling resistance pounds per ton of the train, condition of the track, excellent good is 5, good to fair is 6, fair to poor is 7, 8 is poor, 9 to 10 is poor. Effective weather hauling locomotives met most adverse temperature of the Fahrenheit loss to hauling percentage of weather factor. Above 32 degrees, you have a 100% weather factor. At 16 to 32 degrees, you lost 5%. And then have a weather factor of 95. The O to 0 to 15 degrees plus, you have a loss at 10% and a 90% weather factor. Negative to 10 degrees, 15% loss of the hauling factor, 85% weather factor percentage. 11 to 20 degrees below 0, 20 degrees loss of percentage, 80% weather factor, 21 to 25, 25%, and so on, decreasing in the formula of 5% each, 5 nautical degrees in temperature below zero. Requirements for locomotive type of locomotive type of operation, gallons per train of the mile, gallons per hour. The requirements of the estimated average of the fuel oil consumption, 0660 diesel electric locomotive railroad switches at 2.5 gallons per mile per train to the mile, gallons per hour, 11.5 gallons per hour. 044 Lewis mile diesel electric 112 20-ton road switcher and 9 gallons per mile, gallons per hour, 8 gallons. Chapter 7: Acquisitions of locomotives.